with funding through the HEAL initiative.
Marianne, I'm sorry, I just wanted to mention to everyone that we are recording this webinar with the hopes that we will be sending it out to everybody. We'll definitely be sending out the slides. After Dr. Pelley-Mentor gives her presentation, we will have a question and answer. The way that you ask your questions is through the Q&A field. How do you find that Q&A field on your WebEx? If you hover over the ... you'll see Q&A, and just click on that, and that's where you'll ask. Please use the Q&A to ask the questions. If you have any technical support questions, use the chat for that. All right, with that, I will throw it back to Dr. Pelley-Mentor.
All right, thank you. Right, so the first slide I want to show you, in case it takes some convincing that biomarkers are important, is that multiple studies and analyses have shown that the probability of success for any asset that's going through the drug discovery process is really increased at various stages of the drug discovery and development process by having biomarkers. So you can see that in this particular graph that is from the bioindustry analysis by Thomas, D.W. Thomas. You can see that from phase 1 to phase 2, there's a significant increase looking at the yellow versus the blue bar. And same way with phase 2 to phase 3, and all the way to NDA to BLA, even though it's a smaller increase. If you look at the phase 1 to approval success rate, you can see that without selection biomarkers, the success rate is 8.4%, which has always been, generally it's touted that it's about a 10% success rate. And you can see, at least in this particular analysis, that with selection biomarkers, the success rate from phase 1 to approval goes all the way up to 25.9%, which is a really large increase. Okay, so then this next slide, just want to give you put all of us on the same page, give you a little refresher on some of the definitions that we use in our funding opportunity announcements, and also talk to you a little bit about the way we view the process of biomarker development. So just to start with the definition of a biomarker, the FDA and NIH define it as an indicator of a normal or pathological process or of a response to a therapeutic. Context of use is another term you'll hear a lot, and that really just refers to the manner and the purpose of the use of a biomarker. Another term you'll hear is fit for purpose. That refers to the required degree of validation for the intended use of the biomarker. So in this chevron diagram that we have here, the main point of it is that the degree of validation evidence that's required changes with the stage of discovery and development of the biomarker. So for instance, when you're in the discovery stage, you don't need as much evidence as when you're asking to clinically validate the biomarker or when you're going to the FDA to try to get it qualified. If you look at the types of things that are typically done in these various stages of biomarker discovery and development, you'll see that in the discovery stage, things like just making sure your sample collection and sample resources are standardized is important. You'll be using a lot of bioinformatics. The identification of the biomarker and its discovery will occur during this stage, as well as a pilot proof of concept study, often in humans at that stage. And then the detection method must also be developed during the discovery phase. Moving to the analytical validation phase, there the context of use should be moving from just a hypothesis, which it was in the discovery stage, to something that is fairly concrete. In analytical validation, you would also be establishing the acceptability of the performance characteristics for your detection method. You'd be looking at things like precision, sensitivity, accuracy, and dynamic range when you do that. In the clinical validation stage, this is where you'd be looking at designing large prospective or retrospective clinical studies to cover the full breadth of the context of use of the biomarker. you would be evaluating the overall utility for clinical practice and for drug development. And then finally, in the qualification stage, that would be referring to if you decide to submit your biomarker and the evidence supporting it for the FDA review for qualification. And with this, within the context of use, the biomarker would provide reliable application and would allow specific interpretations once it's qualified by the FDA. And something I should mention right away, as we are not saying that we require FDA qualification for our biomarker applications. It's just something that we suggest, and it's certainly something just in terms of the FDA has a qualification site, and we really strongly suggest that before you send in an application, you go to that site and look at the resources on that site, look at what the FDA looks at in terms of criteria and evidence that's necessary for different stages of validation and discovery, and then look at their program, because having FDA qualification, if you're trying to, for instance, develop a biomarker that will be used in clinical practice, being able to say that it was FDA qualified certainly does add credibility to your biomarker. So again, it's something that we're using as a general standard, but it's not something we're requiring that you do. So it looks like it's not moving. Just a second. I can't get my slide to move. There we go. Okay. So now a couple other terms I'd just like to get everybody familiar with are terms like analytical validation, clinical validation, and clinical utility. Analytical validation, the way we're defining it, is establishing that the performance characteristics of a measurement are acceptable in terms of sensitivity, specificity, accuracy, precision, and other relevant characteristics using a specified technical protocol. And this protocol could include things like sample collection and standardization procedures. The level of analytical rigor that is necessary depends on the characteristics of the biomarker, the detection technology, the type of clinical question, or its intended use as a biomarker, i.e. diagnostic, predictive, or pharmacodynamic. Clinical validation, the way we're defining it, is establishing that the biomarker acceptably identifies, measures, or predicts the concept of interest. Clinical utility is defined as the conclusion that a given use of a biomarker will lead to a net improvement in health outcome or provide useful information about the diagnosis, treatment, management, or prevention of a disease. Now, all of these definitions are coming from something called the BEST glossary, which you can actually find if you go to the FDA biomarker qualification website. BEST stands for Biomarkers, Endpoints, and Other Tools Resource. And again, it contains all these standardized biomarker definitions, gives you some ideas also of definitions and words usually used in the process involved in developing biomarkers. And we have the link here in the slides, which you'll be able to access. So I'd like to start now with, so as I said, we have two biomarker programs. The first one I want to talk about is the Neuroscience Biomarker Program. The goal of this program is to facilitate the development of high-quality biomarkers to improve the quality and efficiency of clinical research, phase 2 and beyond. We'll talk about two types of resources we have for this program. One has to do with tissue and data repositories that all can be, information about them can be accessed through a centralized informational resource site, and that is our NINDS biomarker website, which you can Google and find. The other resource is funding opportunities, and all of these funding opportunities support a rigorous fit-for-purpose validation process for the biomarker discovery and development. And again, the link is on this particular slide to find this information. So to talk about the resources and tools first, and again, this is a link to this particular page that has the resources and tools. One of the tools and resources that we talk about on this webpage is the NIH Biomarkers Consortium. This consortium brings together diverse partners around a common mission to develop biomarkers in order to help accelerate the development and delivery of new technologies, medicines, and therapies for the prevention, early detection, diagnosis, and treatment of disease. If anybody is interested in SNIH, there are application forms if you have an idea. That this has to be put through a fairly rigorous governance process to get acceptance of it or not. But if you're interested in that, please email me and I can give you more information about it. Another type of resource is a consortopedia, and that's just a searchable catalog of nearly 500 profiles on research consortia. Some of the data resources are, especially for traumatic brain injury, the Federal Interagency Traumatic Brain Injury Research, or FITBR resource. That can be, information about that can be found by clicking on this site. There's also the NINDS Human Biomarkers Biospecimen Data Repository, or BioSend. And again, you can get some preliminary information by going to the site and clicking on some of these links. And if you have further interest in it, please just email me and we can actually set you up with this. Another one is the NINDS Human Cell and Data Repository, same instructions. And then we also have the NIH Neurobiobank and the Parkinson's Disease Data Management Resource. And then some of these others, like the FDA resources, are available by clicking the links on our website or just going straight to the FDA website. Now, to talk about the funding opportunities supporting validation of neuroscience biomarkers, we have a number of them, as you can see. PAR 19-315 is for the discovery of biomarkers and biomarker signatures for neurological and neuromuscular disorders. It uses a grant mechanism called an R61-R33, which is a phased research development grant. We'll talk about it a little bit more. That has it's driven by milestones, and the passing these milestones is required to go from the R61 to the R33 phase. Another type of funding opportunity is PAR 18-550. That's analytical validation of a candidate biomarker for neurological disease. That is a U01 mechanism, which is a cooperative agreement, also driven by milestones. PAR 18-549 is just the SBIR, Small Business Innovation Research version of that. So if you're a small business, you could apply to 549. PAR 18-664 is for clinical validation of a candidate biomarker for neurological disease. That, again, is a cooperative agreement U01 mechanism, and the SBIR version of that is PAR 18-548. The next application due dates for all of these are February 14th, so that one's coming right up, and then July 20th, all of 2020. These grants are all reviewed by the NINDS review branch in a special emphasis panel. So they do not go to CSR. Now, just to talk a little bit about the R61, R33 phased award mechanism. So as you can see, it's in two parts, but when you send your application in, you should include both parts. So your application should include a section on R61 and a section on R33. In the R61 part of the mechanism, you could call that phase one. It's the exploratory aspect of it. So this is where we would expect that you would be identifying and discovering your biomarker, verifying that it's reflecting what you think it is, and you'd be developing your detection method during this phase. The length of it, we say can be 1 to 3 years. That can be flexible. The budget is not limited, but must reflect the actual needs of the proposed project. In the R33 phase of this mechanism, this is phase 2, and this, again, we say it can be 1 to 2 years, but again, can be flexible, and the budget is not limited, but must reflect the actual needs of the proposed project. Usually in R33, we suggest that people conduct a very pilot level proof of concept study of their biomarker in humans, looking at an AUC for a ROC curve or receiver operator characteristic curve, where you have actually done an analysis to look at the sensitivity and specificity from a clinical perspective of the brand new biomarker. Total project duration for these two phases is no more than 5 years. So R61 and R33 together have to add up to 5 years. As I was mentioning before, this mechanism is milestone driven. So there is only one set of milestones between R61 and R33. And those should be, we say, go, no go in the way they're set up. So we should be able to make decisions about whether to transition via administrative review to R33 or not. So when you're thinking about setting up your milestones, think about results that you need to see. What would be a showstopper before you would, that would disallow you to go to R33? And they have to be backed up by specific quantitative criteria. Okay, now I want to say a little bit about the U01 and U44 cooperative agreement mechanisms. So for the U01, again, the length is up to 5 years. Budget is not limited, but must reflect the actual needs of the project. In the Small Business Innovation Cooperative Agreement mechanism, the U44s, they have two phases. Phase 1 is up to 2 years. Phase 2 is up to 3 years. In terms of budget, Phase 1 is up to $700,000 per year. Phase 2 is up to $1.5 million per year. And again, budgets must be reasonable, appropriate, and justified according to the approach that's being used. With the U01 and U44, again, milestone driven. This time, instead of just having one set of milestones between two phases of the grant, for the U01s, there are go, no-go milestones every year, so they're annual for this grant for the duration of the 5 years. And again, same idea, you have to be able to make a decision based on the milestones. So when you're suggesting your milestones in your application, ask yourself, could you make a decision based on what this milestone says? And do you have quantitative criteria for success that back up each milestone? So with these, each year, if you do not meet your milestones, you will not be able to proceed to the next year. So again, it's also important to make your milestones realistic and make your milestones pass the red face test. You know, some people might view realistic being as easy. I'm not saying that. I'm just saying make them realistic for the project. You know, I want to tell you a little bit about each of the funding opportunities. So PAR 19-315 is discovery of biomarkers and biomarker signatures for neurological and neuromuscular disorders. The two institutes participating in this are NINDS and NIA, NINDS being the lead. The goal is to deliver strong candidate biomarkers or biomarker signatures for neurological and neuromuscular disorders that are ready at the end of these grants for definitive analytical and clinical validation studies. Entry criteria are a cogent biological rationale supporting the candidate biomarker. It has to have relevance, but not for, there's a mistake on here, not for just, it's for neurology therapeutic development, not pain. Pain can be included in it, but not only pain. Another entry criteria is demonstration of proficiency in the biomarker modality proposed. Projects should be supported by data or publications showing that the investigative team is capable of carrying out the proposed biomarker studies. Some examples of activities that are appropriate for PAR 19-315 is identification and initial evaluation of a biomarker signature for neurological or neuromuscular disorders. I'm not going to go through all of these. Another type of thing is mechanistic and or theoretical and computational modeling to tie the biomarkers to their mechanistic underpinnings. Specifically studies aimed at understanding whether the biomarker is relevant to disease pathophysiology, pharmacodynamic response, treatment pathway, and so on. Bioinformatics and or statistical approaches to support the biomarker identification can certainly be part of this. Development and optimization of the detection method should be part of this. And then proof of concept studies using human tissue, biofluids, or imaging samples to confirm biomarker identification obtained during animal tissue source work is also something that could be part of this. And finally, preliminary clinical validation studies to confirm the biomarker identification is also important. Things that are out of scope are biomarker studies for diseases or disorders that are outside the mission of NINDS. This is why one of the things that we really suggest is if you're thinking about submitting an application to us, it's a really good idea to contact us, because then we can visit this issue right away. Is your project within the mission of NINDS or not? As many of you may know, different diseases are shared by various institutes at the NIH. So an example is Alzheimer's disease. National Institute of Aging takes many applications that have to do with Alzheimer's disease or mild cognitive impairment, but NINDS takes some as well. But we also look at disorders that are related to Alzheimer's disease. So we have these parsed in specific ways, so it's good to find out from us exactly whether your application fits in the NINDS version of it or whether it should go to a different institute. Other things that are out of scope are use of non-standardized sample sources, and I'm just picking and choosing some of these. Prospective design clinical utility or validation studies. Those, as you know, actually are fit for a different funding opportunity that we have. Things like preclinical animal studies without a transition to human studies would also be out of scope. So keep in mind, if you're just proposing animal studies, that is out of scope for this funding opportunity. Development of candidate therapeutics is out of scope for this opportunity. And efficacy testing as the primary intent is out of scope. If you're developing a response prediction biomarker where you actually have to do a therapeutic intervention of some sort using a drug, and you're using that actually to validate your biomarker, that's okay. So this all has to do with the intent of your proposal. Now I'd like to talk about 18550 and 18549. These two funding opportunities support the analytical validation of a biomarker for neurological disease. Goals, of course, are to encourage rigorous analytical validation of your candidate biomarker measure or endpoints in a manner that's consistent with FDA guidelines. It'll involve things like evaluation of the assay, its performance characteristics, and the optimal conditions for performance characteristics. And of course, it has the same goal as all of our biomarker FOAs, which is facilitating the advancement of robust and reliable biomarkers. Entry criteria include having an identified biomarker with a working hypothesis on the context of use already in place. You also need to show that you've developed your method of detection, and you still have it's fine to have further optimization left to do, but you basically need to show us that you're not still developing the method of detection here. Another entry criteria is plans for the management of pre-analytic variables from sample collection to how you're going to deal with things like transfer from pipette to pipette. You need to have a cogent biological rationale supporting the candidate biomarker, and it has to have relevance to therapy development or to clinical practice. Examples of appropriate analytical validation studies include things like determination of accuracy, precision, sensitivity, dynamic range, specificity, and so on for the detection method. Establishment of appropriate quality control and improvement procedures. And then the goal for analytical validation should be that the biomarker measurement meets the FDA analytical performance criteria, or at least, you know, in concept meets these criteria within the scope of the intended context of use. Things that are out of scope for these two FOAs are biomarker identification, because that will occur in the discovery FOA. Things like initial development of the detection method, again, should occur in 315, the discovery funding opportunity announcement. Therapeutic target identification is definitely out of scope. Preclinical animal studies are out of scope. Development of candidate therapeutics out of scope, and studies focused on clinical validation out of scope. All of these things that I just mentioned are covered in other funding opportunities that we have. Now I'd like to talk a little bit about 664 and 548. These funding opportunities are focused on the clinical validation of a candidate biomarker for neurological disease and neuromuscular disorders. The goals are to encourage rigorous clinical validation of a candidate biomarker using retrospective and or prospective methods in a manner that's consistent with the purpose of the biomarker, and to facilitate the advancement of robust and reliable biomarkers, phase 2 and beyond. Entry criteria for this one, again, you have to have an identified biomarker with a working hypothesis on context of use. Your analytical validation for this biomarker should be completed and consistent with FDA standards, again, in terms of the concepts behind those standards. The reason I'm saying that about the FDA standards is that they're mostly focused on fluid biomarkers. And so people coming in with imaging biomarkers or behavioral biomarkers might say this doesn't have anything to do with what we're doing. But if you look at the concepts related to performance of the detection method, things like precision, for instance, or dynamic range, that would apply to all types of biomarkers. Another entry criteria are plans for management of pre-analytic variables. Preliminary validation would have to be in your application. And then, of course, the same things as with all the others, biological rationale and relevance to therapy development or clinical practice. Examples of appropriate validation studies, and again, I'm just going to talk about a couple of the bullet points. Demonstration of association of the results of the biomarker assay with a clinical endpoint such as survival, response, disease presence or absence in samples or data from patients that have been exposed to a uniform intervention or that have or will develop a disease or a disorder. So something like that's appropriate. Definitely appropriate is definition of the sensitivity and specificity of the assay results within the context of the defined clinical endpoint and clinical population. And this is where having the sensitivity and specificity data in the clinical meaning of the two terms would be important in developing your receiver operator characteristic curve and looking at the AUC for that. Estimation of the prevalence of the marker within subjects or patients for the intended clinical context is also appropriate. Things like prospective focused and randomized multi-site clinical studies are very appropriate. And intervention studies where pharmacodynamic, predictive, monitoring, or safety biomarker validation is the focus of the study is fine. Also, it's fine to have non-intervention studies where diagnostic, prognostic, and risk stratification biomarker validation is the focus. Those are all fine. But again, if you have questions about what's appropriate, the best thing to do is just to call us or email us, and then we'll help you set up the call. Examples of things that are out of scope for this clinical validation funding opportunity are natural history studies aimed at exploring disease pathophysiology, genetic or epigenetic mechanisms. So I guess the main point in this bullet is this word exploring disease pathophysiology and so on. We, all of these biomarker funding opportunities are very much focused on delivering a biomarker. So the most important thing is delivery of a biomarker that's clinically validated, or in the case of the analytical validation, FOA is analytically validation, or in the case of the discovery funding opportunity announcement, is a candidate biomarker that looks promising. Other things that are out of scope for this clinical validation funding opportunity is applications that propose any animal studies. So in this particular case, you've already developed you've discovered your biomarker, you've analytically validated it. There is no purpose at all in doing animal studies for this one. Studies of biomarker identification or technology development, of course, were covered earlier, so not appropriate for this one. Applications that propose only to create or maintain patient registries are not appropriate. Clinical testing, again, of candidate therapeutics, not appropriate. Clinical intervention studies other than those necessary to validate biomarkers are not appropriate. But again, it's important to emphasize if they're necessary to validate the biomarkers, then of course clinical intervention studies have to be done. And this is why we've given some flexibility on whether clinical trials or clinical studies are allowed, so we say it's optional. And then applications that request support for infrastructure to establish new trial networks are also beyond the scope of this FOA. All right, now I'd like to move to our other biomarker program, Biomarkers and Endpoints for Pain, which is a program that's included in the HEAL initiative. HEAL meaning helping to end addiction long term. The program goal of this biomarker program is to develop objective biomarkers and endpoints to facilitate the discovery of non-addictive treatments for pain. So we have two funding opportunity announcements for this program. One is for the discovery of biomarkers, biomarker signatures, and endpoints for pain. This is RFA-NS 18041. It uses the R61, R33 grant mechanism. It will facilitate the discovery of robust biomarkers, biomarker signatures, and objective endpoints for pain conditions for use in clinical trial design and clinical practice. The other funding opportunity is analytical and or clinical validation of a candidate biomarker for pain. And you'll see here, with this funding opportunity announcement, we combine analytical and clinical validation into one announcement. So that's different than the Neuroscience biomarker program, where each one has a separate funding opportunity announcement. This one is RFA-NS 18046, again an R61, R33 mechanism. It will support the analytical and clinical validation of candidate biomarkers for use in the discovery and development of non-opiate alternatives to the treatment of pain conditions using retrospective and or prospective methods. And we have one remaining application due date for this program. It is March 12, 2020. And again, if you want to get more information about the HEAL initiative, please click on the link that's in this particular slide. So I'd like to tell you a little bit about RFA-NS 18041, the discovery phase funding opportunity announcement. This particular grant opportunity, NINDS is the lead on this, but we're working with a team composed of many different institutes, from NCI, NEI, to all the way to ORWH. So if you're, depending on what your application focuses on, your team will be tailor-made to include people from NINDS as well as people from the appropriate institutes who can help you. So we try to form a team that can help you right at the time even of your pre-application call. The goal of this funding opportunity is to promote the discovery of strong candidate biomarkers and endpoints for pain that can be used to facilitate the development of non-opioid pain therapeutics from discovery through phase 2 clinical trials. The entry criteria here are just to have a cogent biological rationale supporting the candidate biomarker, and it has to have relevance, of course, for pain therapeutic development or for clinicians who are dealing with pain patients. Examples of activities that are responsive to this RFA are things like, again, it's similar to the other discovery funding opportunity, identification and initial validation of a potential pain biomarker, identification and validation of objective pain endpoints, a comprehensive set of biomarker discovery studies designed to identify a set of mechanistic markers associated with diverse pain conditions, including identification of combined biomarkers that form a signature for the selected pain condition. So that includes things that are multimodal types of biomarker signatures. It includes algorithms, all sorts of things like that. Proof of concept studies using human tissue, biofluids, or imaging samples to confirm the biomarker identification obtained if you happen to start off your work with animal tissue sources. And so this is again what This is the discovery version of this, just like with the neuroscience discovery biomarker funding opportunity. Animal studies are involved in these discovery phase opportunities, but the whole idea is that you have to move from animal work, animal studies, to human tissue or human clinical samples for your R33 stage, which has to include some sort of proof of concept study in humans. And then another thing that's okay is preliminary clinical validation studies to confirm biomarker identification. Examples of things that are not responsive to this RFA, again, are the natural history studies, if they're really aimed more at understanding disease pathophysiology, mechanisms, things like that. Biomarker identification or validation based only on animal data without confirmation using human tissue sources or preliminary clinical validation is not allowed. So you have to, if you have animal, again, I can't stress enough, you have to move to human in these funding opportunities. Use of non-standardized sample sources is not responsive. Large prospective clinical design validation studies are not responsive because we cover that in another FOA. Again, preclinical animal studies without transition to human studies not allowed. Development of candidate therapeutics not allowed, and biomarker discovery outside non-addictive therapeutic options to pain conditions is not responsive for this. And then to the last funding opportunity I was going to talk about, this is the combined analytical and or clinical validation of a candidate biomarker. And again, this is in conjunction with many institutes within NIH, all who have an interest in pain and cover different aspects of pain. Entry criteria for this one are that the biomarker signature endpoint has to be identified, and you have to have a working hypothesis regarding the context of use before you can get into this funding opportunity. Method of detection should be developed. There should be supporting data showing that. Cogent biological rationale and evidence for an unmet need needs to be in your application. You need to show relevance for therapeutic development, and the focus of the biomarker signature endpoint has to be on a specific pain condition. Things that are responsive are things like analytical validation of detection methods, where the biomarker is likely to be used as a tool in diagnosis and treatment of pain. And then analytical and clinical validation of biomarkers that do not involve clinical intervention, such as diagnostic, prognostic, or susceptibility risk biomarkers, but also analytical and clinical validation of biomarkers that do involve clinical intervention. Again, it depends on the biomarker. If it's a pharmacodynamic or predictive response prediction biomarker, you have to do a clinical intervention to validate. Rigorous evaluation of the sensitivity and specificity of the biomarker signature endpoint is responsive, and then, of course, retrospective or prospective, well-controlled multi-site clinical studies are responsive. Things that are not responsive, similar to the other clinical validation, funding opportunity announcements, applications that only propose animal studies, natural history studies aimed at exploration and mechanism rather than developing the biomarker, development or clinical testing of therapeutics, and applications that request support for infrastructure, all are not responsive. So general guidelines for both the neuroscience program and the HEAL program for pain are that the goal for the discovery phase is to have a candidate biomarker endpoint with a developed detection method and preliminary validation in human samples by the end of the grant period. So this is what we're looking for the discovery phase funding opportunity grants. For the validation phase funding opportunity announcements for both programs, the goal is to have a well-validated, reliable, and accurate biomarker that's appropriate for the context of use developed by the end of the grant period. Also, it's essential to understand in a very specific way the context of use for your biomarker. This provides the framework for your experimental design. You should ask yourself how the proposed biomarker will improve the efficiency and quality of clinical trial design, or how it will transform decision-making for practicing clinicians relative to what's already available. And these are things you would want to argue in your application as part of the unmet need and the reason for having the proposal in the first place. Another thing is analytical validation involves multiple facets, including how to handle sources of sample variability, pre-analytic variables, and overall performance of the detection method. Clinical validation also involves many facets, including understanding and optimizing clinical sensitivity and specificity across the breadth of the disease population to be assessed. And I want to point out that when you're using the term sensitivity and specificity in the clinical context, sensitivity refers to whether or not your biomarker is picking up like all possible examples of the actual disease or the issue that you're trying to have, what the biomarker is supposed to reflect. Specificity refers to whether or not your biomarker picks up false positives and how many false positives does it pick up. In the analytical validation context, sensitivity is how small an amount of the biomarker is contained in the matrix and is still reliably measured. And specificity is whether or not it's accurate and it's actually picking up what you expect it to. So that's the end of the slides that I have. This last slide shows all of the links to all of the funding opportunities I've just described, so you can actually pull up these funding opportunity descriptions and look at them. We have a link to the websites, and we have emails for both myself and Dr. Bachman there. So ready for questions.
And like we mentioned earlier, we will be sending out these slides to everyone, so those links will be live when you get when you get that slide deck. So let's start off with the questions. The first one: can there be a biomarker study without an intervention component, or should the first 2 years be to confirm the biomarker phenotyping and then test it with an intervention study?
All right, so again, from like just going through these slides, a lot of this, the answer to this question depends on what kind of biomarker this is. Not all biomarker studies require interventions. If by intervention you mean a drug intervention or, some sort of behavioral intervention. So it just depends on what you're trying to show. In the first 2 years, usually what people do is they, do whatever they need to identify the biomarker. They develop the detection method, and they do correlation studies, sometimes with the mechanism for the biomarker, just to make sure it's reflecting what they expect it to. Sometimes actually, clinically, depending on if it's a behavioral biomarker, for instance, they're going to have to do it either maybe like if it's pain in a human model of pain, something like that. But usually that's done the first, I'd say, I've never seen anybody so far come in with just 2 years for R61, but, whatever you think you can do. Usually people are taking about 3 years to do all of that.
Okay, next question. For the R61, R33 mechanism, can you describe the type of milestones you are expecting to see?
Yeah, so again, these have to be milestones that you could, if you were looking at them, could you make a decision about whether or not the project is ready to move to R33? So one of the things you're doing is you're looking at correlations between your biomarker and what it's expected to measure, or with a mechanism of action, something like that. What's the range of correlations you would like to see to convince yourself that it's actually doing what you expect it to? If you're looking at the detection method, what does the preliminary precision look like on that? Is it something that looks reasonable when you look at, for instance, the FDA guidelines, or just, the guidelines that you think are scientifically feasible, or your statistician suggests? Things like that would be a milestone, because if it looked like you were absolutely, not close to these things, and that there was danger that you would not be able to proceed to do proof of concept, then, it would be a no-go. So again, think go, no-go. All right?
Does receiving an R61, R33 affect early investigator status?
And I think it would, because the budgets on these, since most of these are clinical studies, the budgets are fairly high, and I think this would negate your early investigator status. We don't advise people to use these if they're trying to maintain EI, early investigator status.
Next question. How many awards for biomarker development will be issued in 2020, and what is the impact cutoff score for funding these awards?
So I don't have specific answers for that, but I can tell you, I mean, this is a fairly new program. So for the Neuroscience Biomarker program, we've had like 2 rounds where we've actually looked at applications that have come in and decided to fund or not to fund. 1 round we did not fund any. Actually, 2 rounds we have not funded any. The very first 2 we did not fund any. The 3rd round we funded, we funded 5 out of about 21 or something like that. And we're getting similar numbers of applications for an additional round that we're looking at right now. So that maybe that could be a guide for how many we fund. And cutoff scores, really, we do not percentile these because they go through a special emphasis panel at NINDS, so we use the actual impact score. And so we don't really have a cutoff. We look at ranges that look like they might be fundable, and they vary from application round to application round. Just so things like what reviewers say in summary statements make a big difference. And if we think that you might have something in the fundable range, we do a due diligence process, and we allow you to respond to the reviewer's comments, and then we have a call. So it's a long process, in other words, and it depends on. It's kind of like when you take a test in college and you're being graded by the curve. It depends on how people are looking each round.
Next question. For a TBI biomarker, can we propose validating a biomarker panel rather than a single biomarker to be used as a prognostic measure of health outcome for disease management and monitoring therapeutic efficacy?
Absolutely able to, no problem using a panel. Now, when you talk about using a panel, though, one thing I think you should think about is the practical side of this. So if you want this biomarker to be broadly used, how would physicians who are not researchers use this panel? Would there be an easy way, a very clear and repeatable way of deciding whether or not the person is going to show the phenotype of the disease or whatever it happens to be? So think about those things. When you say panel, think about exactly how it will be used.
Next question. For a U44, is the objective to come up with a biomarker such as an ELISA to eventually commercialize?
That it's not required, but people will propose this. It's not something that specifically has to happen. I don't know, Julia, do you have any?
So SBIR applications, this is typically for a fast-track only type of phased mechanism, and you will have to provide a commercialization plan within your application. So it is, your ability to commercialize will be judged by a reviewer. Although it's not absolutely required, it's a big component, yes.
Next question. Can you recommend a consultant who's familiar with FDA biomarker qualification?
The only people I can think of are people who are actually at the FDA. Maybe we should take that offline, and I'll think about it. You have my email address, so why don't you just email me, and I'll see if I can come up with something.
What about non-traditional biomarkers like imaging biomarkers? I'm developing imaging biomarkers for functional imaging in 3D printed patient in chip models. So it's a marker for pain physiology in a high throughput tissue screen.
Yeah, so that is fine. I mean, so basically we take pretty much any type, any modality of biomarker, including imaging and, even behavior. I mean, anything. So the important thing is the science behind your proposal, the preliminary data you have to convince reviewers that it's feasible, and again, this whole thing about how will it be used in the end in the field and how useful will it be. So think through not only the science but also the practical use of your biomarker.
A big impediment for an SBC like us is access to well-characterized human serum, CSF, from severe TBI patients with associated clinical data, such as initial GCS, intracranial pressure, GOS scores, etc. Can NINDS provide such a resource for our grant?
So that one, depending on exactly what you need, there is a possibility that they can. And again, it might be a good idea for this question to email us, and we can put you in touch with some of the people who deal with TBI here. For instance, Pat Belgowan does. So we could talk to you about FITBR.
Okay. Next question. Would a study in which the goal is to evaluate whether the presence or absence of a particular imaging sign can classify or determine the precipitating factor for a specific pain condition and thereby predict the response to surgical treatment qualify for any of these heal mechanisms?
Yes.
Okay, and just as a reminder, for anyone who would like to ask questions, it's in the Q&A field. We had a question, can I download the slides? Yes, we will be emailing these slides to anyone who is registered for the webinar, and in a perfect world, we will also be sending out the recording as well. The next question, do we need to show preliminary data to apply for an RFA NS 18041?
I think you need to show some preliminary data just to show that the theoretical underpinnings of your biomarker idea have some basis in reality. I mean, really, because the reviewers are going to want to get an idea of the feasibility of what you're proposing and whether or not it makes any sense. So anything you can do, you have to, like any grant proposal, you have to make an argument for why this is needed, why it makes sense from a biological perspective, and why it might be feasible.
Okay, and just to give everyone a heads up, we do have room at the front of the line right now if you have any questions. We have about 5 minutes left in the webinar. We have a question. Are you on social media, or do you have any future webinars from your group scheduled? I can answer that. We are on Twitter, and our Twitter handle is @NINDS and that is our Twitter handle. We are also on LinkedIn, and the benefit for following us on those social sites is that we do advertise other webinars. We advertise when some of our project officers are going to be at conferences, so you can set up meetings, or any, new funding initiatives are released, that's where we release them. In terms of future webinars, there is a Blueprint Neurotherapeutics webinar next Thursday at 3:30 Eastern, and you can reach out to me if you want more information about that. Our next question. Are brain biomarkers of pain measured as EEG signal qualify for a HEAL program?
Yes, absolutely.
Okay. How should we engage pre-application consultation for a proposal that would involve multiple institutes?
So again, probably the best way to do that is to email us. And then we, between Tim and Julia and myself, we will help schedule a call between you and your team. So you would be responsible, of course, in getting, availability and things like that from your team, but we do this all the time.
While proposing a biomarker panel, what are your tips for not being viewed as a fishing expedition?
So I think a lot of it has to do with the rationale that you're going to provide. Is there a cogent, again, this gets to the whole cogent biological rationale. Is there a really good reason from a scientific perspective why you've chosen to, like, scan through a particular panel? If you're doing metabolomics or something, can you narrow it down based on what you think about the biomarker and what its context of use is going to be? So a lot of it depends on your explanation. We certainly have had metabolomics, genomics types of biomarker explorations come in, but again, it all has to do with your approach, your explanation, and so on. So just make sure that part is focused and you have a good reason for it.
Okay, with that, we've come to the end of the webinar. I wanted to thank Dr. Perlmutter, Dr. Bachman, and, of course, everyone who joined. Please let us know if there's any way you think we can improve these webinars, or if there's any webinars that you have not heard from us that you would like to have done. We're all ears on this. So thank you very much, and good luck to everybody.